u is equal to fxy. This is the utility function of any consumer, and the budget constraint is given by x px plus y py equals to m. This is the budget constraint of the consumer. So what you have to do is that you have to maximize this utility subject to this constraint. So you'll form the Lagrangean function, which is f of xy plus lambda m minus pxx minus pyy. Okay, so what you will do is that you will find three partial derivatives, one with respect to each variable and one for the constraint. So del L by del x, which is say Lx, is fx minus lambda px equals to 0. Del L by del y, just say Ly is fy minus lambda py equals to 0, and del L by del lambda is m minus pxx minus pyy equals to 0. So this is equation 1, 2 and 3. So you can write equation 1 as fx equals to lambda px, and equation 2 as fy equals to lambda py. Dividing 1 by 2, what you'll get is fx by fy equals to px by py. This is what you'll be getting. And what is fx by fy? F of xy, they are the, x and y are the two arguments of the utility function. So fx is basically del f by del x, fy is basically del f by del y, which should be equal to px by py. But what is del f by del x? This is marginal utility of x upon marginal utility of y. And what is mu x by mu y? That is nothing but mrs. And what is px by py? This is the price ratio which you have. So at equilibrium, mrs should be equal to the price ratio. Okay, now what you will find is that how to calculate the second order conditions, how to find out whether second order conditions hold, and this indeed is the maximum point. So what you will do is that you will form the bordered Hessian. What you'll do is the bordered Hessian. So HB in this case would be equal to 0, px py, px py. These are the first order partial derivatives of the constraint, and these are the second order partial derivatives of the objective function. So fxy, fxy and fyy. So this is the matrix, and you will try to calculate the determinant. So you have calculated this determinant. This is the bordered Hessian determinant, and in case if this is positive, then this is the case of maxima. Okay, that is so what you will do is that you'll just calculate it and expand it along the first row, and you'll be getting this value, okay, which is minus px square fyy plus 2px py fxy minus py square fxx. So all of this should be greater than 0. Okay, for in case if this has to be the point of maxima, or you can write this as px square fyy minus 2px py fxy plus py square fxx should be less than 0. Okay, so in case if you just multiplied this by minus 1, and you can substitute, well, in case if you go back to the first order conditions, you have fx by fy equals to px by py. This is what you have. That is, you had fx by fy is equal to px by py. So you can substitute px as py into fx by fy. So what you will have is, instead of px you will write py into fx by fy square fyy minus, in place of px again you will write py into fx by fy py fxy plus py square fxx should be less than 0. Okay, so simplifying this, you will have what you will have. I don't have space here. So what you will have eventually is py square, okay, fx square fy square fyy minus 2 py square fx by fy fxy plus py square fxx should be less than 0. This is what you will have. Okay, now in case if you, what you'll do is, this is the inequality which you have. So in case if you multiply both the sides by fy square by p square y by py square, what we'll have is, you have to multiply, I'll just write this equation again, which is py square fx square fy square fyy minus 2 py square fx by fy fxy plus py square fxx less than 0. Now in case if you multiply both the sides by fy square into py square, so what you will have eventually is fx square fyy minus 2fx fy fxy plus fy square fxx less than 0. This is what you will have. Now this is also the condition, okay, for in case if, now this condition is going to be satisfied in case if indifference curves are convex from below. So I want you guys to see one of the recording earlier in micro course, which is that in case if you have fxy equals to z, okay, this is the function which you have, and you have to find out whether diminishing marginal utility would imply diminishing MRS or the other way around. That is one of the condition which you have, and there we have proved that this condition has to be satisfied in case if diminishing MRS has to hold. So please guys look at that recording as well. So this was the case for consumer equilibrium using Lagrange multiplier.